Expansion of liquid. When a liquid is heated, it is done by keeping the liquid in some container and supplying heat energy to the liquid through the container. The thermal energy supplied will be partly used in expanding the container and partly used in expanding the liquid. Thus, what we observe may not be the real expansion of the liquid. Hence, for liquid, we can define real expansion and apparent expansion. For a liquid, we should observe a real expansion and apparent expansion. What is real expansion? If a liquid is heated directly without using any container is a real expansion. But practically it is not possible. The coefficient of real expansion is defined as the ratio of the true rise in the volume of liquid per degree rise in temperature to its volume. What is apparent expansion? If you heat a liquid by using a container, the heat energy partly utilized by container and partly used by a liquid. What we observe is not the actual expansion of the liquid. For that, we have to observe the expansion of a liquid without considering container. This expansion is called as apparent expansion. This is the experiment to measure real and apparent expansion of liquid. First, the liquid whose real and apparent expansion is to be determined is poured in a container up to a level and mark the level as L1. Now, heat the container by using a burner. Initially, the container receives the thermal energy and it will expand. If you heat the container first expands. As the result, the volume of the liquid in the container reduced. The reduced level of liquid is marked as L2. And further heating, the thermal energy supplied to the liquid through the container. That result in the expansion of the liquid. Now, the level of the liquid rises and marked the level as L3. L1 is the initial level. L2 is the reduced level of liquid due to the expansion of container. L3 is the level of liquid rises due to expansion of liquid. Is it clear? Now the difference between the levels L1 and L3 is called apparent expansion. The difference between the level L2 and L3 is called a real expansion. By this way, we have to calculate the real and apparent expansion of the liquid. The real expansion is always more than that of apparent expansion. Hello children, in this video we are going to learn chapter 3 Thermal Physics. Sun is the primary source of thermal energy for all living organisms. Thermal energy is the cause, temperature is the effect. All living organisms need a particular temperature for their survival. Temperature is defined as the degree of hotness of a body. The temperature is higher for a hotter body. The temperature is lower for a colder body. Temperature is the property which determines the direction of flow of heat. It is a scalar quantity. There are three ways to measure temperature: Fahrenheit, degree Celsius and Kelvin. But the SI unit of temperature is Kelvin. What is absolute temperature? It is also called thermodynamic temperature. It is the temperature of an object on the scale where 0 is taken as absolute zero. The 0 in the Kelvin scale is absolute zero. 0 Kelvin is the absolute scale of temperature of the body. Let us consider the two bodies, the body A and body B. The temperature of body A is 0 degrees Celsius. The temperature of body B is 100 degrees Celsius. If two bodies are brought in contact with one another, the heat energy will start to flow. We know that the heat energy is always flow from hot body into cold body. Here, the flow of heat starts from body B to A. As a result, the temperature of body A will increase. The temperature of body B will decrease. This process will continue until these two bodies attain the same temperature. After attaining the same temperature of 50 degrees Celsius, the flow of heat will be stopped. This is thermal equilibrium. Next, thermal energy. If you leave a cup of hot coffee on a table for some time, what happens? The hotness of the coffee decreases after some time. What do you infer from this observation? Here, there is a flow of energy from the cup of coffee to the environment. This energy is termed as thermal energy. Heat energy is the agent which produces the sensation of warmth and make bodies hot. The process in which heat energy flows from a body at a higher temperature to another object at lower temperature is known as heating. This process of transmission of heat may be done in any way like conduction, convection or radiation. The process of transmission of heat through conduction. What is conduction? The transfer of energy in the form of heat from one object to another by direct contact. For example, if you stir the hot coffee by using stirrer, after few seconds, if you touch the stirrer, you will feel heat. Here, the heat will transfer from hot coffee to stirrer is called conduction. Next, convection. Convection is the mode of transfer of heat which occurs mostly in liquid and gases. Here, heat transfer takes place with the actual motion of matter from one place within the body to the other. For example, in hot water at the bottom becomes lighter and moves upward and forcing the colder and denser water at the top to come down and thus heated up. This mode of transfer is called convection. Another form of heat transfer is radiation. It does not require any medium. For example, in winter, we sit near a fire and we feel very warm without touching the fire. In radiation, the heat transfer in the form of rays. So only it does not require any medium to transfer heat. The SI unit of heat energy is joule. There are some other commonly used units. They are calorie as well as kilocalorie. A calorie is commonly defined as the amount of heat required to raise the temperature of 1 gram of water through 1 degree Celsius. Characteristic features of heat energy transfer. We come across all the types of heat energy transmission. From that, we can conclude heat always flows from a system at a higher temperature to a system at lower temperature. The mass of the system is not altered when it is heated or cooled. The mass remains unchanged. For any exchange of heat, the heat gained by the cold system is always equal to the heat lost by the hot system. Heat gained equal to heat lost.